Hello students, today we'll go for a new topic, an interesting topic, that is functions. So before entering to the main concept function, we should know the basic concepts like what is a set, how to represent a set, and what are the types of sets. And the main concept, the set concept gives the relation between the relation and a function. Now we'll see one by one what is a set. What is a set? In mathematics, a set is a well-defined collection of distinct objects, or we can have, instead of objects, we can have elements, is called as sets. So what is well-defined? Means the collection of which kind of collection we have to consider. This well-defined means it should be a unique. It should not change from a person to person. For example, if I ask what are the natural numbers less than 10? What are the natural numbers less than 10? So the answer may be a unique, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a collection of natural numbers which are less than 10. So this is a collection. And it is a well defined, because if anyone can answer this, anyone can give the same answer, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. One more example. Vowels in English alphabets. Vowels in English alphabets. So what will be the answer? The vowels in English alphabets are A, E, I, O, U. So these are the vowels. So it is a collection of vowels in English alphabet. One more question. If I ask the collection of favorite Tollywood heroes. Tollywood means Telugu heroes, Telugu actors. This may not be a unique, because some of the persons may have their favorite hero is Prabhas, or some of them may have Chiranjeevi, some of them may have Pawan Kalyan. So this collection will be vary from person to person. So it is not unique. So this collection is not well defined. So this collection of favorite Tollywood heroes will not come under, it is not well defined, because these heroes may be vary from a person to person. It is a not unique. So what is a set means? It is a well defined collection of distinct objects. One more example we will see. One more example. What will be the collection of even natural numbers less than 30? So the answer may be a unique. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 and 28. So these are the well-defined collection of elements, or we can say objects, which are even natural numbers less than 30. Now we'll go for how to represent a set, and it is, let's see one by one. These sets are represented by capital letters like capital A, capital B, capital C, etc. And the objects, whatever we are collecting, the objects or elements that are represented by the small letters A, B, C, and they are enclosed by the flower brackets or curly brackets. For example, we have discussed one example, the collection of vowels in English alphabets. So it is a set. Assume that A is a set of A, comma, E, comma, I, comma, O, comma, U. So it represents a set. It is a well-defined collection of distinct objects. And what are this collection is? It's a vowels in English alphabets. This is unique. And one more example. The set of natural numbers less than 10. So B is another set, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, which are natural numbers less than 10. So it is a collection of objects which are less than 10. And these are the elements separated by commas. Now we'll see the forms of these sets. So there will be two types of sets, that is set builder form and roster form. So the representation of a set. There are two forms of representing a set, that is in roster form or we can say tabular form. The another one is set builder form. So what is a roster form? A roster form is a simple that we can collect all the elements and keep in set. Whereas set builder form, if we can write in short, that should satisfy a common property. So we'll see the definition of a roster form as well as set builder form. So roster form. So in this form, the elements of a set are listed and separated by commas. Means we have to identify all the elements and represent in a flower bracket. That is example A, E, I, O, U. It is in roster form because all the elements are listed. And one more, so instead of that, we can use one more form, that is set builder form. In this form, all the elements are, so this is for as set builder form. In this form, all the elements of a set possess a common property, we can say common variable, which satisfies by each member of the set. For example, this is an example of vowels in English alphabet. So how can we represent this list in set builder form? By using the common property. So that is, we can write x is a variable such that x is a, what type of elements? These are, x is a vowel. So it may be A, I, O, O and U. A, E, I, O, U. So X is a vowel in English alphabets. So it represents a set builder form. What is the purpose of writing in set builder form? Suppose if I ask the question, write the set of elements, set of natural numbers which are less than 100. If you go for a rostered form, so what we can have? it is 1, 2, 3, 4. We have to write all the elements up to 100. So it will be a time taking process. So instead of that, we have to go for set builder form. And what is the condition? It is a x such that x is a natural number less than 100. So this is in set builder form. Let's see few more examples on roster form as well as set builder form. So the example is the collection of odd natural numbers less than 30. So in roster form, so we have to list all the elements, that is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. So these are the elements in roster form. So in order to write in short, we can go for a set builder form. That is, x is a odd natural number, that is x such that x is a odd natural number less than 30. So this is a set builder form. So all the elements means this set consists of all these elements. So where x is a variable which satisfies the common property that is less than 30. It should be a odd natural number less than 30. Next, we'll go for types of sets. Empty set. What is an empty set? It is a set with no elements present in the set. Is called an empty set, or the another name of empty set we can write we can say is null set or void set. And it is represented by pi. It is represented by pi or just no elements in the set. Now, for example, if I give that, suppose a student is studying in both class 9 and class 10. For example, x such that x is a student studying in class 9th and class 10th. Then how many will be there? Yes, a student can't study simultaneously both 9th and 10th. So there will be no students who are studying both classes at a time. So this is an empty set, means no elements in the set. It is called, this is an example of an empty set. Next, one more set, it is singleton set. It is a set with only one element in the set. Is called an singleton set. A set with only one element. For example, you are well known with prime numbers. X such that x is an even prime number. You are well known with prime numbers. Among the prime numbers, which of them are even? Only 2 is a even prime number. So what is x now? It is 2. and 3, 5, 7 are odd natural numbers, and this 2 is the only even prime number. So it is a singleton set. It is a set with only one element, and this is an example of a singleton set. Next, now we'll go for equal sets. Two sets A and B are said to be equal if they have same elements present in them. Then same number of elements, and we write as A is equal to B. If they are not same, then we can say they are unequal, and we can represent as A is not equal to B. For small example, if I give, that is example, if A is a set X such that X is an even prime number, is one set, and you know the answer, that is only 2, because it should be a prime number and along with even, so it is 2. Next, B is another set X such that X satisfies the equation X minus 2 is equal to 0. Means it is an equation. What is the solution? X minus 2 is equal to 0 means X is equal to 2. Means these are the two sets, and in this, what is the elements? 2, and here also 2, because X minus 2 is equal to 0, the set of all solutions comes under this set. As it is a linear equation, it will have only one solution, that is 2. So these elements are same. So we can say that A is equal to B. A is equal to B. Now we'll go for one more, that is finite sets and infinite sets. So finite sets and infinite sets. Finite set is a set having finite, or we can countable number of elements, which in the set which we can count them, then that type of sets are called finite sets. If we are unable to count how many elements exist in the set, then that type of sets are called infinite sets. So the finite sets are also called countable sets. Why? Because we can able to count how many elements are present in the set. For example, if A is a set of A, E, I, O, U, how many elements exist? 1, 2, 3, 4, 5. So it is a countable set, and this is the finite set. Finite set. Let us take one more example, B. B is a set of consonants. Otherwise, we'll go for natural numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is also a finite set. One more example, consonants, means consonants of English alphabets. There will be 26 alphabets normally. From that, if you remove the vowels, then you will be getting the consonants. 21 letters, that will be a finite set, because there will be 21 elements in the consonants. One more example, if I go for 1, 2, 3, 4, 5, so on, then can we say it is a finite set? No, because we can't able to count how many elements are there in the set. So this is an example of an infinite set. infinite set. So that is the difference between finite set and infinite set. Next, we'll go for what is a subset. Subset. Assume that there are two sets A and B. Set A is said to be a subset of set B if every element of set A is also a member of set B. Then it is called a subset and it is represented by A is a subset of B. One small example, that is A is a set of the classes in your school. So what will be the classes? You may have first, second, third, fourth class, fifth class, so on up to 10th, high school. Now B is a only one class. Consider your 10th class, only 10th class. Means in set A, all the students will come under the set A. So the students of class 1, students of class 2, students of class 3, students of class 4, class 5 up to class 10. All the students will be present in the school A, set A. Now coming to the next set, only class 10. Only class 10 means only few people will be in the another set. Now every element of set A is a member of B, or every element of set B is a member of A. Every student of class 10 is also a student of this set school. This one. Every student of class 10 is also a student of this set, the school. Every student of class 10 is also a member in that school. So we can say B is a subset of A, where A is called the superset. So let me brief in one more example. A is a set of 1, 3, 5, 7, 9. And B is another set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is 1, 3, 5, 7, 9 and B is another set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what we can decide is every element means all the elements of set A is also a member of set B, or every element of set B is a member of set A. That is, 1 is a member in set A as well as in set B. 3 is also a member in A as well as B. 5 is also a member of both A and B. 7 is a member. So all the elements of set A are also a members of set B. Means we can say A is a subset of B. If I go for one more, that is A is one set 2, 3, 4. B is 1, 3, 5, 7, 9. Assume that these are the two sets. Now decide which of them are subset, like A is subset of B, or B is a subset of A, or it is not a subset. Now 2 is a member of set A. In this B, 2 is not there. 3 is a member of set A, but 3 is also a member. 4 is also not there. Means 2 and 4 elements are in set A, but that elements are not present in set B. Means we can say that A is not a subset of B. A is not a subset of B, because if any one of the member of the set A is not a member in set B, then we can say A is not a subset of B. So the concept of subset is very, very important, and we can find out for given any set. Suppose if A is equal to 1, 2, 3, we can find some subsets of this finite set. That is, for this 1, 2, 3, what are the subsets we can form is A1, singleton 1. 1, if we consider this is a subset of capital A. A2, 2 is also a member, A2 is a subset of A. A3, singleton 3. A3 is also a subset of A, because 3 is in A3, 3 is the element, and 3 is also a member of set A. Next, A4, 1, 2. If this is 1, 2 is one set, 1, 2 are the elements of A4, and the same 1, 2 are elements of set A. So we can say A4 is a subset of A. Similarly, A5, 1, 3 is also a subset. 2, 3 is also a subset. Next, A7, that is 1, 2, 3. Every set is itself a subset because they are equal. Next, A8, which is empty set. Every empty set is also a subset of the set. So these are the 8 subsets we can form from one set, that is A is equal to 1, 2, 3. So let me give one more example. Let's see one more example. If A is a set with elements A comma B, how many subsets we can form? How many subsets are there for set A? So that is, A1 is empty set. Every empty set is a subset to A. A2, singleton set A comma A. A is a set, A belongs to A2, and the same A belongs to capital A. A3, B, singleton B, and A4, A comma B. Every set is itself a subset to A. How many subsets are there? 1, 2, 3, 4. Means if a set consists of two elements which are finite sets, then the number of subsets are 4. In general, note, every empty set is a subset to set A. Suppose if A is a set, then every empty set is a subset to set A. Next, B. Set A is itself a subset. Means every set is itself a subset. Next, third, if set A has n elements, assume that there are n countable elements, that are n, then the number of subsets of A are 2 to the power of n elements. 2 to the power of n subsets we can form. For example, if A is equal to A, B, C, D, how many subsets we can form is 2 to the power of 4. 2 to the power of 4, that is 16. We will list all the 16 subsets now, and we can go for few more examples also. So if A is a set with elements A, B, C, D, so how many elements? 4. Now how many subsets we can form with this set A? From this note, every empty set is a subset to set A, means empty set is a subset, and singleton sets A, B, C, D are also subsets of set A. Next, the sets of with 2 elements AB, AC, AD, BC, BD, CD are 2 elements which are also a subset of capital A, because every element of this set is also a member of set A. Next, set of 3 elements ABC, ABD, BCD, ACD, and these are the subsets of capital A. And the last is a set A itself a subset, means ABCD is also a subset to itself. So these are the 16 subsets which we can form. So based on the subsets, we'll go for a relation. From the relation, we'll go for the actual topic function. So thank you.